Today I'll talk about isochoric process with numerical example. Here is the problem statement. Consider an isochoric process for 2 moles of an ideal gas with following parameter. So initial state P1 1 atm, V 24.635 liter and T1 300 Kelvin. Final state P2 is 2 atm, V is same 24.635 and T2 600 Kelvin. Gas constant R is equal to 0.08206 liter atm mole Kelvin and heat capacity CV, that is 3R by 2 monoatomic ideal gas. Now here we have to calculate that Q and internal energy del U. So here we know that in isochoric process volume remain constant. So V is constant. So no work is done. W is 0. All energy transferred as heat goes into increasing the internal energy of the system. Now here I am giving here the PV diagram. So here that V is constant and that state from 1 to 2. So in that state 1 T1 is 300 Kelvin and V is 24.63 liter and P1 is 1 atm and state 2 P2 is 2 atm and T2 is 600 Kelvin as V remain constant, so volume is 24.63 liter. Now before going to do the problem, here are the key equation. So for isochoric process volume is constant, so W is 0 and heat transfer Q is nothing but NCV del D and internal energy change, that del U is equal to NCV del T. And first law of thermodynamics, del U is equal to Q plus W, and PV is equal to nRT. Now here step by step calculation. So calculate the temperature change del T. Del T is T2 minus T1, so that is 300 Kelvin. And then calculate the molar heat capacity CV. So for monoatomic ideal gas CV is equal to 3R by 2. So CV 3 into R 0.8206 liter atm mole Kelvin by 2. So that will give 0.12309 liter atmosphere mole Kelvin. Now calculate the heat transfer Q. Q is nothing but NCV del T. So N is here 2 mole. CV already we got 0.12309 liter atmosphere mole Kelvin and del T is 300 Kelvin. We already calculated here. So ultimate Q will be 73.854 liter atmosphere. So calculate W. W, as it is a isochoric process, volume is constant, so W is 0. For isochoric process, remember W is 0. So now after getting Q and W, so we can calculate the internal energy change. So here internal energy, the del U, first law of thermodynamics, we can write del U is equal to Q plus W. So W is 0, so Q is 73.854 liter atm. So change of internal energy is 73.854 liter atmosphere. And convert to kilojoule, that is optional, you can do that. So the conversion factor liter atm to kilojoule is 0.1013 kilojoule per liter atmosphere. So we can convert that del U is nothing but 7.484 kilojoule. So here is the result summary. So work done, W is 0. So no work is done during isochoric process. So V is constant. And then heat transfer Q is 73.85 liter atmosphere. So heat added to the system. Internal energy change del U is nothing but 73.85 liter atmosphere equal to the heat transfer because W is 0. So del U is equal to Q plus W. So W is 0. So del U is equal to Q. Internal energy change del U. So in kilojoules 7.48 converted to kilojoules. Now here is the key insights. In an isochoric process, since the volume remain constant, no work is done by or on the system. All heat added to the system goes directly into the increasing the internal energy, resulting in a rise of temperature and pressure. These are the key insights. That's it for isochoric process. Thank you.